Welcome all. This is Gary. So today in this session, I will try to continue this playlist of statistics. Well, as we know, the statistics in data science and in data analytics and machine learning especially is very important. So for the reason, I try to share with you some key questions kind of facing an interview or when we try to build in our project in data science in general. Well, as we see here, so in this notebook, I try to import some packages that kind I need here to answer my questions. So the first one here I have Seaborn, so Seaborn, and also we have MATLAB Live. Well, in Python to import that, we cannot just using these keywords of import, and also here as alias to give a short name for our packages. Well, the first question we're facing here, as we see, what is the benefit of using box plot? Well, the box plot, it's in Seaborn. Well, we use it to show the five number summary. I will show you now how that. Well, for so to show you this box plot, I using this Aris dataset. So it's famous one here. It's a exists in Seaborn for a purpose education. For so anyone interested in science gonna try to discover him skills or her skills. So here in this data set, well, we have data equal to SNS. So I mean, is born or Seaborn here dot float data set. So we see the function integrated in these packages or in this module or in this class where I give the name of dataset here. In our case, is Aris. Okay, I read the five top records here as we see. We have five independent variables, and we have dependent one. I mean the target one here. Species is the name of iris or the name of flowers. All the flowers we have here. So for iris dataset, it's not binary classification. We have three classes after, so we have three classes possible here. Okay. Well, here this is the box plot here. How we can apply this box plot using Python. So as we see, we have box plot. We have data because source of data of our data sorry is data. Well, I give the payload width here just a chosen one, and I give it the title based on MATLAB Live here. So plt.title, I give it a title to understand what's happening here behind this figure. Well, this is the box plot. Okay. So here this is the minimum values. Okay, the minimum values here, and here we have 25% of data. Okay, we kind of see here in these x classes how much we have here in this straight line here in the middle. Okay, it's a median or 50% of data. Here we have 75%, and here we have maximum. And each point or dot point is out of the range or out of these five summary numbers. That's what's called outliers. Well, the rule or the principal rule for box plot is to detect outliers visually. We can do that here when we see these dots here out of this box or mean. I mean the extremes of distribution or of data. That's what's called outliers. Okay. So let's see the second question here. What is the meaning of standard deviation? So in descriptive statistics, we have this concept of standard deviation. Well, it's represent how far are the data point from mean. So we see here this mathematical formula here. We have sigma with the Greek sample here equal to root of all the elements we have in our data minus the average squared divided by n the number of sample or the number of elements we have in our sample, because standard deviation is exist in a descriptive statistic. And when we talk about descriptive statistics, we mean samples. Okay, we can now work with population. And variance is the square root of standard deviation, because when we are calculating the standard deviation, we square it and it's coming standard deviation. Or variance is squared, or standard deviation when we square it, we come into uh, variance? Well, simply because when we see the distribution of our data based on some variables at this time, we can asking ourselves how the what is the more far point compared to the mean of data we have. Well, this concept of standard deviation or variance it's coming to explain for us or give us some values here to see how this data is far from each other. What is the max point here? Standard deviation is very important because we give us the variation of data how it is. Well, if we see the example we have here behind this arrays data set we have, I tracing some columns here. Okay, I using data.columns, and also we have data.simple with it. I call this function of standard deviation. It's available here. As we see, we have this value of 0.4358. We have number here, range of numbers. Well, this is the standard deviation. What is mean that? When we go to simple widget here, so simple widget here, all the values we have here, the simple of 150 simples. So for this data set we have, the variation or the standard deviation of this column is 0.43. Okay, that means all the variation or all the point we have here for this variable is around this value of 43. Okay, this is the value here. So that's what I mean. That's the meaning of standard deviation or variation in general. It's very important concept also. Well, let's continue our list or playlist here for questions. The question three: what is the left skewed distribution and the right skewed distribution? So this concept also is very important because in real world project we're facing this kind of distributions. So we can now facing the Gaussian or normal distribution. I will show you the difference of all the distributions we can facing. Well, here in this case, so the left skewed, the left side is longer than right side. The mean, statistically, the mean is less than median, is less than mode. Well, we were talking the skewed left. When we see the distribution like that with this function of distribution, we see the extremes. I mean, the left side and the right side is different. When we're talking in case of left skewed, that means the tiles or this line or this curve of in a left side it's more than right one. We mean that the center of data is not is the left. Okay, the center of data is in the left because uh left side. I mean that the left side is here. Okay, in this case here when we see with camera the left side here, that means the tiles of this curve is more than the right one. That means center of data is coming on the left. That's what's called left side. Also, we have right side. Right tail is longer than the left side. The same thing. When we go in the left side, or right side, sorry, the curve here what we see, the curve. I mean the tail of this curve is more than left one here. I mean the mode is more than median is more than mean. Here the mean center of data is coming to the left one here, the left here. This it's outlier between brackets. Okay, that's what's called the outlier because we have some data it's out of the range here. Well, that's we have some strategies to handle it. Well, so if we come into fifth question here, what is the relationship between mean and median in normal distribution? Whoa, the perfect one, the perfect distribution here. And for any data scientist, any engineer of machine learning is which facing this kind of distribution. Well, the answer in the normal distribution mean is equal to median. Why? Because in normal distribution, I will show you that before in practice in the next sessions. When we talking about a normal distribution, that means we have the equal or the left side is the same the right side. We have a normal here, and the advantage of that, the measures. I mean, the mean is the mean is the same the median. The value of mean is the same of median because the center of data is concentrated in the middle. Okay, we don't have the right or left side. The data is concentrated in the middle of this shape. a bit of bell curve. Because when we're talking about normal distribution, we have also standard normal distribution, and then we review the reasons why we're using the standard normal distribution, not normal distribution, also because we have the infinity of values on all these things. I will discuss that in the next sessions. Well, we have also, so when we come into five functions here, what does mean by curve or bell curve distribution and Gaussian distribution? Well, normal distribution is called bell curve distribution. Why? Because we have this curve is built like that. We have similarity. Okay, we have similarity of this curve. The right side is the same left side. Or we have also the Gaussian distribution. It's called bell curve because it has the shape of bell. It's called Gaussian distribution, as is named after the scientist Carl Gauss. So we call it Gaussian distribution. We inspired this name for scientist Carl Gauss. We have this curve like that, beautiful shape. Okay, we have similarity. I will show you that before, after. Just here is the theoretical. I will give you just some answers because in some interviews you can face this kind of answers. Some this kind of ask this kind of key questions. Sorry. Well, if we come into six questions here, how to convert normal distribution to standard normal distribution. That is very important because we can't see the shape like that. It's a normal distribution, but we want standard normal distribution because we have the infinity of values. When we go to this function of cumulative density function, when we give to this function any values at this time, we can go to infinity. So for this reason, we need just small range and any value or any input to these functions, we can give us answers just in this small interval of 0, 1. Standardized normal distribution has been mean equal to 0. So when we talk about standard normal distribution, that means mean is 0 and standard deviation is 1. That means the maximum value we can have face or the more far element in this samples is 1 and the mean is 0. That's what's called standard normal distribution. So to convert normal distribution to standard normal distribution, we can use formula of standardized. I mean, we can we can use we can have we can see any values or any elements in these samples. We extract the mean divided by standard deviation. At this time, we can standardize all elements. So we can see that in practice. So if you have 15 elements, that means each value of these 50 elements, we extract the mean of these samples divided by standard deviation. That's what's called standardized normal distribution. So if we continue in this playlist, we have seventh question, sorry, is not six. How we can do with outliers? Because as I tell you before, we cannot face in the outliers in any problems. At this time, we need to be ready to handle these missing values. So remove outliers. So the first strategy we can do to remove outliers, we will know that point is wrong. Example, negative age of person. Sometimes when we see some columns or some features, we check all the values possible at this time. If we take an example of age, so there is no ability to see the age negative. There's no meaning. For the reason, the best strategy we can use here is to remove these values. So when we call law of data, we should provide true analysis. Well, if we have a lot of data, a lot of records, maybe millions of records, at this time we can lead to analysis with outliers. At this time we have outliers. So when we have a lot of data, we can actually provide two analysis, one with outliers and other one without outliers. I mean, if we have a lot of data, we cannot draw, cannot draw to conclusions, to different conclusions. That means we can lead in the project with two strategies. The first one with outliers, we can making our analysis with outliers, and the second part or the second things is to lead or building our project without outliers. And we can compare the result at this time. We can see and draw the final conclusions. So if we keep in outliers, first one is the remove outliers, and the second one is outlier. When we do a lot of outliers to the data, maybe right or left. When results are critical, when are meaningful. Sometimes these outliers it will be meaningful, especially when we working with some techniques. So TSNA, PCA, LDA at this time, these outliers can have meaningful because we want to cluster maybe, okay, between brackets. We can cluster the groups to understand how these things behave. Sorry. So at this time, the outliers have a meaningful. So we have some cases we need to keep the outliers. Uh, in case if we have a lot of outliers, at this time there is no ability to drop it. We have low outliers in our variables. How we can do that? Or sometimes we have skewed data, a lot of skewed data in the left on the right. At this time, there is no ability to group all these things. Or we have critical results. That means we have meaningful results based on the outlier. There is no ability also to drop all these things. Okay, so data scientist or real data science, it's so between brackets for this reason I need to domain knowledge. It's very important that okay, just it's not it's not enough really to apply this part technical. We need to have strong background or a domain knowledge to do that. So if we go to 8 questions, okay. So 8 questions. What is the difference between population and parameters and simple statistics? So this is a fundamental questions. Why? Well, I will show you why. So population parameters. We have some parameters. We have mean. We have mu. We're using this Greek symbol, me like that. We have also standard deviation. We're using the other one, others symbol Greek like that. So this in the population parameters, we have population. We using both of these Greek characters. Okay, and for simple statistics, we have x bar, and we have standard deviation. It's called S. Well, in statistics, we have population and we have simples. I will show you now what is important in that. So we see now the 9 questions. Why we need simple statistics? Why we need simple statistics? The answer: population parameters are usually unknown. Hence, we need simple statistics because, as I tell you before in last session, there is no ability to see or to know all the information for some population. If we take in for example of weights of all the population we have in the world, there is no ability to know all these things. There is no ability to know each or the head or for each people in the world. For the reason we need just some samples. We take in just simple with some strategies, with the random or with some other techniques. Okay. Well, I will give you now example to see how that is important. So the question 10: how to find the mean length of all the fishes in the sea? Just if you look in this question, how it is. We have the sea and we have a fish inside of the sea. How we gonna know the length of each single sea? Just how we can imagine how number of the fish we have in the sea. The thousand million of fishes and types of fishes. For this reason, the statistics is coming here to solving this kind of problem. The first step we can do here, define the confidence interval because that is called inferential statistics. I mean, we try to draw our conclusion based just on simple. Okay, we can take in some simples here, random simple. At this time, we can conclusions. So some conclusions or draw conclusions based on simples. So the second step, the confidence interval in the most common is 70, is 95%. The confidence interval that means the probability the probability of if this the probability of so we have this interval confidence. I mean the how what is the probability if this mean? So in this if we take in this example of mean, what is the probability of mean of the sample that's coming in this interval? That's what's called confidence interval. In the most common we have 79, okay, 95%. What is the probability of this mean or land mean of these fishes? It will be in this interval. That's what's called the confidence interval. The second step, taking a sample of fishes from sea. Okay, we are taking samples from the sea. some simples, random simples, or maybe we have some other technique. So to get better results, we the number of fish will be more than 30 because in the test statistics or other tests, so we have this criteria. The number of fishes will be more than 30. So for this reason, we need to do that. Well, say the third step here is to calculate the mean length and standard deviation of lengths. I mean, we take in simple, we calculate the mean each time for each simple we have here. Okay, we calculating the mean and the standard deviation. And the final or the fourth step here, sorry, calculating the test statistics. Okay, we calculating the test statistics. Why? Because the mean of population is in no way. At this time, we need just to draw a conclusion based on this kind of test. Okay, we have because we have just the mean and standard deviation of population provided, not for population. Sorry, the mean and standard deviation of samples is provided, not with not the mean and the standard deviation of population. Well, so get the confidence interval in which the mean length of all fishes should be. I mean, after we calculating the t statistics with this hypothesis and these things, we need to specify or calculate our interval. Okay, to find the confidence interval here, we which the mean of length after calculating the mean of all the fishes here based on the samples or random samples we taken from the sea. What is the interval or confidence interval in which the mean length it will be? Okay, that is inferential statistics. I mean, after calculating all these things, we try to draw a conclusions based on samples here. So this is the power of statistics, how it's coming. We can solve in complex problem just with statistics and try to generalize the results or try to draw conclusions just based on samples. And that's what we try to do in machine learning and in data science also. When we're working with algorithms on all these things, it's just it's the same logic behind. We try to generalize. Okay, after descripting, we predict, and we have descriptive domain to try to understand the result and try to do some solutions based on this prediction we have here. Because we have samples, we train it, we give it our model, we train the model, we make a prediction. After the prediction, we have prescription. We need to analyze and understand these predictions, why, to give some reasons, to give some solutions. Okay, that is the process. That's how the process happens. Well, I hope you to understand that, and I see you in the next sessions with other questions. Okay, see you again, and bye bye, and happy learning for each one.